Hello children. In the previous video I gave you introduction about matrices, how many types of matrices are there and how can we form a matrix if some property or some rule is given to us. Now in this video I am going to tell you about the operations on matrices. There are three operations, that is addition, subtraction and multiplication by a scalar. One by one we are going to discuss these operations. The first one is addition. One important thing for addition of matrices is that the matrices to be added should have the equal order. Then only the matrices can be added. For example, I have taken matrix A, its order is 2 by 2. Matrix B is there and its order is 2 by 2. Since both the matrices have got this equal order, therefore these matrices can be added. So A plus B will be equal to 3, 0, 2, 9. First I have written matrix A plus then the matrix B is 5, 8, 6, 9. And for the addition of matrices it's very simple that their corresponding elements will be added. So element at the first position for first column, and in this matrix B also 5 is at the position first row first column, so they will be added. Next is 0 plus 6, 2 plus 8, 9 plus 9, and now you just have to simply add the elements, or you just have to apply the rules of simplification. So it is 8, 10, 6 and 18. Similarly, if now we have to find B plus A, in that case first I have written the matrix B plus now the matrix A. Now again their corresponding elements will be added, and the matrix is coming to be 8, 6, 10 and 18. So you can see that both the matrices are equal. We have A plus B is equal to B plus A. This means the addition of matrices is commutative. The way we are having the addition of matrices, exactly same way we have the subtraction. For this again the condition is that the order of the matrices should be equal. I have taken matrix A as 3, 6, minus 8, 9 and B is 4, 9, 1, 0. Now we are calculating A minus B. So in this case first we are writing the matrix A, then minus sign, and second is matrix B. Now in this case again the corresponding elements will be subtracted. So it will be 3 minus 4, 6 minus 9. The position is should be same. Minus 8 minus 1, 9 minus 0. So it comes out to be minus 1, minus 3, minus 9 and plus 9. That is A minus B. Now let us calculate B minus A also. In this case, first we are going to write the matrix B and then matrix A. And it will be 4 minus 3, 9 minus 6, 1 minus of minus 8, 0 minus 9. And it comes out to be 1, 3, 9 and minus 9. Now if you compare the matrix A minus B and B minus A, you can see that both the matrices are not equal. That means the subtraction of matrices is not commutative. You can see what is the difference. The difference is of the sign. This is equal to minus of A minus B. Right? You can see the elements differ by a negative sign. So A minus B is not equal to B minus A, and it is equal to minus B minus A is equal to minus of A minus B. Now the third operation on matrices is multiplication of matrix by a number. It's very simple. Let the matrix A be 5 minus 3, 9, 0. Now if you have to calculate twice of matrix A, in this case it will be written 2 times of matrix A, and each element of the matrix get multiplied by 2. So it is 2 5s are 10. 2 into minus 3 minus 6. 2 9s are 18 and this is 0. Clear? If you have to calculate minus of A, it is very simple. It will be minus 1 times of the matrix A, 5 minus 3, 9 and 0. Now in this case each element will get multiplied by minus 1. So minus 1 into 5 minus 9. This is minus 9. It will be plus 3 and 0. Simple. Now matrix B is minus 12, 6, 3 and 15. If we have to find out 1 by 3 of B, it will be 1 by 3 of this matrix, and in this case each element gets divided by 3. So minus 12 by 3 is equal to minus 4. 6 by 3, 2. 3 by 3 will be 1 and 15 upon 3 will be equal to 5. So when it is in division, what happens? Each element get divided by that particular number. So these concepts will be more clear to you. I'm going to take the questions from the exercise. Before that, let's discuss. I'll just brief out all these properties. The first is a plus b is equal to b plus a. That is, addition is commutative. Similarly, a plus b plus c is equal to first matrix A plus b plus c. So this is what? This is your law of associative. This is associative. The addition of matrices is associative also, right? Next is A plus null matrix. This is equal to null matrix plus A is equal to A. That means if null matrix is added to any of the matrix, it is not going to make any difference, and we will get the same matrix again. Fourth property is A plus minus of A, that is negative of A. This will be equal to minus of A plus A, and it is equal to null matrix. Simple. If and otherwise also you know this thing, if suppose number is 5 and if minus 5 is added to this number, what we get is 0. Similarly, the case is if matrix is there and negative of matrix is added to it, we are going to get the null matrix. Next property we have is x plus a. X is a matrix, A, B, all three are matrices. Then x plus a is equal to b. Matrix X can be written as equal to B, and this will be taken on the other side minus A. It is simple, as we are having the properties when we solve the equation. When you transpose to the other side, the sign gets changed. So plus A will become minus A here. So matrix X will be equal to B minus A. Let us start the exercise which is based on these properties. Exercise 9b, question number 4. If 6m is equal to 0, 6, minus 12 and 24, find the value of m. 6m is given to be equal to this. We have to find m. How can you find m? Is this is 6m upon 6. That is, on both the sides we are dividing by 6, or in simple form you can say m is equal to this 6 will be taken on the other side. It will come in the denominator. M is equal to 1 by 6 of this matrix. Now in this case what happens, as I told earlier, each elements get divided by 6. 0 upon 6 is equal to 0. 6 upon 6 is equal to 1. Minus 12 upon 6 minus 2, and 24 upon 6 is equal to 4. So matrix M comes out to be equal to 0, 1, minus 2 and 4. Next, question number 9. Find a matrix X such that X plus this matrix is equal to 3, 1, minus 5, minus 2. Students, it is based on the last property which I explained just now. That is, x plus a is equal to b, then x can be written as b minus a. So same thing I am doing here. X will be equal to what? RHS matrix as it is. This is 3, 1, minus 5, minus 2, and minus, we are taking it to the other side. It will come with a negative sign, 4, 6, minus 3 and 7. And after this it's a simple, you just have to subtract 3 minus 4, 1 minus 6, minus 5, minus of minus 3, and this is minus 2 minus 7. So 3 minus 4 minus 1, 1 minus 6 minus 5, minus 5 minus 3. When you will simplify it, what will you get? Minus 5 plus 3, which is equal to minus 2. Minus 2 minus 7 is equal to minus 9. So the matrix X is minus 1, minus 5, minus 2 and minus 9. I hope the questions are clear to you. They are very, very simple questions. Question number 12. Matrix A is equal to 6, 2, 5, minus 4, and B is equal to 1, 2, minus 5 and 1. You have to find a matrix X such that 2A plus 3B minus 5X is equal to 0. I have written here once again, this is 2A plus 3B, and X, when you will take it to the right hand side, it will become positive 5X. So matrix X will be equal to what? 1 by 5 of 2A plus 3B. I'll repeat it. We are having 2A plus 3B minus 5X is equal to 0. When you take 5X to the right hand side, we are getting 2A plus 3B equal to 5X, and X will be equal to 1 upon 5 of 2A plus 3B. Now I am going to calculate what is 2A plus 3B. This is 2 times matrix A plus 3 times matrix B. So this will be 12, 4, 10, minus 8, plus this will be 3. 3 into 2 6, 3 into minus 5 minus 15, and 3 into 1 is 3. And on simplification, 12 plus 3 15, 4 plus 6 10 when we are adding the corresponding elements. 10 plus minus 5 is equal to minus 5. Minus 8 plus 3 is equal to minus 5. And now I am going to substitute value in equation 1. So x is 1 upon 5 of 2a plus 3b. This 2a plus 3b can be replaced by 15, 10, minus 5, minus 5. Now each element will get divided by 5. So 15 upon 5, 3. 10 upon 5, 2. Minus 5 upon 5, minus 1. And this is again minus 1. So we have got the value of matrix X as 3, 2, minus 1, minus 1. Clear, students? Now see, next question number 16. In this, some trigonometry is also used. We have sin A, and this is first matrix, plus cos A into this matrix. So it's a simple, each element of this will get multiplied by sin A. Sin A into sin A, sin square A. This will be minus of cos A into sin A, and sin A into cos A is cos A into sin A, and this will be sin square A. Plus sign as it is. Now cos A will get multiplied by each element of this matrix. It will be cos square A. This will be cos A into sin A. This will become minus sin A cos A, and this will be cos square A. Now these two matrices are in addition, so their corresponding elements will be added. This is sin square A plus cos square A. This minus cos A sin A and plus cos A sin A. This is plus cos A sin A and minus sin A cos A. We are adding them, but since this term is negative, so it will come out to be negative. Sin square A plus cos square A. Now we are applying the square identities of trigonometry. Sin square A plus cos square A is equal to 1, and this will get cancelled. Minus cos A sin A plus cos A sin A, 0. Similarly, this also gets cancelled. It is 0, and this term will be equal to 1. And what is this known as? This is identity matrix of order 2. I2. It can be written as I2. That is the identity matrix of order 2. Now see one more question from this exercise. Find the value of x and y. This is given. Find the value of x and y. This is 2 times of x 7 9 y minus 5 plus 6 minus 7 4 5 is equal to 10 7 22 15. So first this 2 will be multiplied by each element of this matrix, plus this second matrix is equal to, this is given. Now simply the corresponding elements will be added. This is 2x plus 6, 14 minus 7, 18 plus 4, and 2y minus 10 plus 5 is equal to, this is given in RHS 10 7 22 15. Now these two are equal matrices, and we know that if two matrices are equal, then their corresponding elements are equal. So this gives you 2x plus 6 is equal to 10. 14 minus 7 equal to 7. No need of this. Now we are going to take this term in which y is there. This will be 2y minus 5 is equal to 15. So on simplification of this, you will get x is equal to 2. And on simplifying this, we are getting y is equal to 10. So students, this is all what we have in the second exercise of the matrices. And it's very easy. You can practice, you can try the questions from this exercise. Now the next topic which I am going to explain is multiplication of matrices. It is very important topic from this chapter. Definitely you are going to get one question based on this multiplication in your board exams also. Now you need to understand it very carefully. Suppose A and B are two matrices which are to be multiplied. A is of order m cross n, and B, now the first thing which I am going to tell, which is very important in this, is the multiplication of matrices is possible only if number of rows, number of columns, this is the number of columns of first matrix is equal to number of rows of second matrix. Number of columns of first matrix should be equal to number of rows of second matrix. then only the multiplication is possible. So if A is of order m cross n and matrix B is of order n cross p, then the order of the resulting matrix will be having number of rows of first and number of columns of second. I'll give you example, then it will be more clear to you. Let matrix A is of order 2 by 1. Matrix A is of order 2 by 1. Then according to this, what should be the order of B? In the order, the important thing is how many rows B is having. It should be equal to number of columns of A. That is 1 by. Now, number of columns can be any number. Suppose I am taking 1. A is of order 2 by 1 and matrix B is of order 1 by 1. So, the order of the resulting matrix, that is the product matrix, will be what? It will be 2 by 1. This will be 2 by 1. This is the important condition we are having. What is the important condition? That is number of columns of first matrix should be equal to number of rows of second, then only the multiplication is possible. Okay, I'll give one more example regarding the order. Suppose matrix A is of order 1 by 2. Then matrix B should have order 2 by, now it can be any number, I am writing 3. Matrix A is having 1 row 2 column and matrix B is having 2 rows and 3 column. Then the product matrix will have what? It will have 1 row by 3. Its order is 1 by 3. That is, it will have 1 row and 3 columns. So again, please take care of this. This should be equal. If matrix A is of order 1 by 2 and matrix B is also of order 1 by 2. A is of order 1 by 2 and matrix B is also of order 1 by 2. In this case, their product is not possible. Why the product is not possible? Because this condition is not satisfied. Number of columns of second is not equal to, number of columns of first is not equal to number of rows of second. Therefore, this product is not possible. So remember students, whenever you have to do the multiplication, this is the first step which you have to check. Now how this multiplication is done, I'll explain you with the help of example. Matrix A is of order, matrix A is 1, 3, 2, minus 1 and B is 2, 1, 0, 3. Now order of matrix A is 2 by 2. Order of matrix B is again 2 by 2. So you can check number of columns of this is equal to number of rows. Therefore, the multiplication is possible. Right? Now see how we are going to multiply. I have written, you need to write it in a proper order. If it is A into B, first write matrix A, then matrix B. So, what do we have in this is, we are starting with the first row of this matrix and first column of second matrix. First row of first and first column of second matrix. So, what will you have? The first element will be multiplied by first. It will be 1 into 2 plus second by second. This will be 3 into 0. Right? This is the first row, first column of the product matrix. So we are going to take first row of this and first column of the second matrix. And their corresponding elements are multiplied and added. See next one. This is the position first row, second column. First row, this is the first row and this is the second column. So we are going to take first row and second column and their corresponding elements will be multiplied. So you will have 1 into 1 plus this will be 3 into 3. 1 into 1 plus 3 into 3. Right? Now this is second row, first column. So we are going to take the second row and first column, their corresponding elements are multiplied. 2 into 2 plus minus 1 into 0. 2 into 2 plus minus 1 into 0. Now this is second row, second column. So we are going to take this second row and this second column, 1, 3. 2 into 1 plus this will be minus 1 into 3. Right? Now simplify this. It will be 2 plus 0. This will be 1 plus 9. Then 2 2s are 4 plus 0. And this will be 2 minus 3. And this is equal to 2, 10, 4 minus 1. This is the matrix A into B. Okay, now I am taking B into A. Same method is there, but it will be more clear to you. B into A, the important thing, first write matrix B, then write matrix A. Same, we are following first row, first column. So it will be 2 into 1 plus 1 into 2. Right? First row, first column take. Now first row, second column. So 2 into 3 plus 1 into minus 1. Right? Now I am taking second row and first column. 0 into 1 plus 3 into 2. Then second row and second column. This is second row and this is second column we are taking, and we are going to multiply the corresponding elements. I will hide this and I am hiding this. So this is 0 into 3 plus 3 into minus 1. Right? And now you can write down, this will be what? 2 plus 2. 2 3s are 6 minus 1. This is 0 plus 6. And this will be 0 minus 3. This is equal to your 4, 5, 6 and minus 3. This is the product matrix B into A. Right? So you can check from here that A into B is not equal to B into A. Clear? So student, this is all we are having in the multiplication of matrices. I have just given you the introduction about this, and in the next video we are going to take more questions based on this multiplication. So try this, go through the examples of the third exercise also. Right? This was the question number 5 from the exercise I have done. Right? So please complete the exercise 9B and go through the examples of exercise 9C. Thank you, students.